Hey, Michael. You had sent me a question in messages about this series RLC circuit. You had said there was a couple questions that you found as you were finishing up series RLC circuits that you didn't know the answers to. And I sent you a message back with the answers for the question, but I thought I'd include this little video too, which should help you understand how to do a question like this too. So if the question is, we have a 50 microfarad capacitor connected in series with a coil to a supply of 120 volts at 60 hertz. The circuit current for this circuit is 6 amps, and it is a lagging current. And the watts for the circuit are 200 watts. So that's the circuit we're given, and we're asked to find the resistance of the coil. Okay. So to do a question like this, the very first thing you should do is draw the triangles out for the circuit, for the capacitor, for the coil. Whenever we do a series RLC circuit, there are 3 triangles that we can do for it. We can do an impedance triangle, a voltage triangle, and a power triangle. They should always be in this order: impedance followed by voltage followed by power. When you learned this in second year, you might have had circuit, capacitor, coil on the top and impedance, voltage, power along the side. It's just a slightly different way of showing the triangles. This works just as well too. This is how I normally do them. Okay, and then once you've got these drawn, triangles for the circuit, triangles for the coil. I only have a vertical line for the capacitor because the capacitor has no resistance, so there is no horizontal side to it, and all the triangle is for capacitor is a vertical line. And once we have those drawn, all we want to do is put down the values that we know for sure on this question and then go from there. So what we know for sure is that the watts for the entire circuit is 200 watts. That goes on my power triangle. Watts always goes on the horizontal. So 200 watts goes there. I also know if the voltage of the circuit is 120 volts, on my voltage triangle for the circuit, the total is 120 volts. I also know that the capacitor is 50 microfarads, so I can figure out the XC of that capacitor. XC is 1 over 2 pi F C. So 1 divided by 2 times pi times frequency times capacitance in farads. Or you can go 1 over 2 times pi times 60 times 50 microfarads as farads would be 6 decimal places back. So 0.00050. 1, 2, 3, 4, 5, 6. 6 decimal places back. And what you should get for XC is 53.05 ohms. So my capacitor has a capacitive reactance of 53.05 ohms. Okay, that's what we know for the circuit. Now, we're looking for the resistance of the coil. So here's the impedance triangle for the coil, and we're actually looking for this side of it, R of the coil. And because we don't know anything really for the coil right now, that's a pretty tough place to start. And what we really need to do is work with the triangles we have and the information we have on them to try and find the values that we're looking for. So what I'm going to try and do is work the information I know from the circuit triangles and from the capacitor triangle backwards to the impedance triangles for all of them, because it's a resistive value on an impedance triangle that I'm looking for. So if I go to the circuit, I know that I have 200 watts. I also know that to go from one triangle to the next on series circuits, all I ever need to do is multiply by the current, if I know the current of the circuit. Multiply by the current to go from impedance to voltage, from voltage to power. We just multiply by the current of the circuit. A lot of times that's a value we have to find. In this case, we were given the current of the circuit. So we already know what it is. That makes moving between triangles here pretty easy. One thing I can do is take this total voltage times the current to give me the total VA. 120 times 6 is 720 VA. So the VA so that 720 VA is the total VA of the circuit. I could figure out the bars of the circuit as well because I know the VA and the watts now. I just use Pythagoras' theorem. The VARs would just equal the square root of the volt amps squared, 720 squared, minus the watts, 200 watts squared. And that would give me, when I figured that out before, 720 squared minus 200 squared, square root of that, 691.7 VARs was what I got. Okay, because I know all the values of this triangle, I can go backwards now and find all the values on the impedance triangle for this circuit. If I just multiply by the current to go from impedance to voltage, from voltage to power, all I have to do is divide from the current, divide by the current to go backwards from power to voltage, and from voltage to impedance, just divide again by the current. Or if I want to go right from the power triangle right to the impedance triangle, I just divide by the current squared. To go right from the power triangle right back to the impedance triangle, I can just divide by current squared. So now I can find some of the values for the circuit impedance triangle, which I'd like to know. And the values that I come up with, if I take 200 watts divided by 6 squared, I get 5.55 ohms as the R of the circuit. If I divide the 691.7 VARs by 6 squared, the current squared, I get 19.21 ohms for X net. And if I divide 720 by 6 squared, I get 20. So the Z total of the circuit is 20 ohms. So now I've found all the values for the impedance triangle. Okay, what we are looking for is the resistance of the coil. If the coil is the only device in this circuit that has resistance, we said earlier the capacitor doesn't have any resistance in it unless they specifically tell us it does. This capacitor has no resistance in it. So whatever the total resistance of the circuit is, that resistance must be the same as what the resistance of the coil is. It's the only thing that has resistance. So our coil resistance is 5.55 ohms. And that's the value we were looking for the circuit. So that's the value of the resistance for that coil, and that's the value we were looking for in the circuit. Okay? Hopefully this helps you to see how to do these kinds of things in a series circuit. Another thing we could have found out too, this is one question that can be a little tricky on a series circuit like this. If they had asked us for the XL of the coil, how would I find it? I know that the total, the net value of reactance is 19.21 ohms. I also know that the XC of the capacitor is 53.05 ohms. Now, XL, how would I find it? Would I take 53.05 minus 19.21? Do I have to do something different? There's one word in the question that is a key for us to know how to find the XL in this circuit, and that key is lag. If the overall current in the circuit is lagging, that means whenever we have a lagging circuit, it is an inductive circuit, which means the XL for my inductor, that value has to be bigger than my XC if the net is going to be overall XL. So I should put X net. I could even put XL because it is inductive in the end, this X net. So in order for XL to be bigger than this, I have to add the XC and the net to get my total XL. The XL for that circuit is going to be 53.05 plus 19.21, which is 72.26 ohms. So the XL of the circuit is larger than the XC by that much, and that's why the current in the circuit is lagging. The circuit overall is inductive. So you can find the XL of the coil, you could find the Z of the coil now. There's lots of questions you can ask with a circuit like this, and hopefully the way I showed you how to do these triangles will help you solve questions like this. Hope it helped, Mike. That's it for now.